All right, number 7, we also want to do a composition of functions here. So I want to also show you another method for doing the composition of functions. Instead of doing it all at once, you can do one at a time. So we are given h, and this little hollowed out circle is composition. H of f is what we're looking for, and we want to plug in -1. So I'm going to give you the symbolic form. What we're doing is we're going to take the h equation, and in the place of x, we're going to replace that with f equation, and we're going to plug in a -1 for where the x should be. So it's pretty much like a double plug-in. So what we're going to do when we do this, we're going to work inside out. So we're going to start with f of 1. So the f equation is x to the third plus 3x. Okay, we're going to plug in a -1 there. So the -1 to the third plus 3 times -1. This is going to give us -1 times -1 is a +1 times another -1 is -1, and then 3 times -1 was the -3. So this gives us -4. So f of -1 is equal to -4. We're going to take this value and plug it in right here. So now instead of h of f of -1, we're looking for h of -4. So now I'm going to go to the h equation, and I'm going to plug in -4. So the h equation is just 7x minus 3. So instead of h of x, we're going to do h of -4. So it's going to be 7 times -4 minus 3. And 7 times -4 gives me a -28. 28 minus 3 gives me a -31. Okay. So this is another way you can do composition of function. Just plug in one number to one inside function first. Once you get that solution, take that answer and then replace it and plug it into the other equation. So I call it like a double plug-in. Number 8, we're given these functions and we have 4 parts. We're going to write and evaluate the function, write the domain, and put in interval notation. So n composed of p, or n composition of p. So that's going to be n of p of x. So I'm going to start with the n equation, which is x plus 4. So the x plus 4. In place of the x, we're going to replace the p of x equation. P of x is x squared plus 9. Plus 9x, that is. So here's my n of p of x. First of formulation, then p of x plus 4, which is kind of what we have written down here, kind of going step by step, and then actually write it out. So we have x squared plus 9x plus 4. And then the domain of p. P is a quadratic. It is all real numbers. There's no square roots, no rational, so no denominator, and no logs that we see. And then the domain of n, which is a linear function, is also all real numbers. So negative infinity to positive. The domain for n composition of P is going to be the overlap of those two domains. So usually when I try to find the domains, I'll do both of them and kind of stack them on top of each other. And wherever they overlap, that's where the final domain is. So let's say that one of these functions was cut off and it only used values of x from, let's say, 6 to infinity. So they would overlap at this part, 6 to infinity. Okay, and so you would use that domain. But however, since they're both negative infinity to positive infinity in this case, that would be the domain of n composed of x.